Our main focus for today, we are looking at physics, tension lesson 104. Remember, there is lesson 101, 102, 103. This is 104. Let us start. This is one of the questions from the question paper. We can see that there is no tension, but this chapter is basically under that chapter, which is tension. Now, looking at the question, it's saying a constant force F pulls a 50 kg block at a constant speed over a rough horizontal surface AB, is shown in the diagram below. The coefficient of kinetic friction between the block and the surface is 0.4. Now, this is our scenario. We can see the diagram based on the scenario. The first question, draw a labeled free body diagram showing all the forces acting on the block. Now remember, a free body diagram, we represent an object using a symbol dot, and then we look at the scenario. We know that we have normal force since this object is on top of a surface. And then we have Fg. And then since this surface it's rough, so there is kinetic friction, and then we also have this force. So our free body diagram will be something like this. So this will be our force applied, this will be our Fg, this will be our normal force, and then this will be our Fk. Now remember, if the mark allocation is 4 marks, it means we have 4 forces acting on the block. If it's 5 marks, you should know that we have 5 forces acting on the block. Now moving on to the next question, it's saying calculate the magnitude of the force. So you're looking for this force. So looking at the scenario and the free body diagram, this is what we have. Now remember, in order for us to calculate this F, we start by writing F net is equals to ma. That is Newton's second law. And then we know that the motion of the system will surely move this direction. Now we need to consider all the forces which are parallel to the displacement of the system. So we can see that this force is not parallel to the system, and this one. We know that they will cancel each other inside the equation, so we might as well not write them. Now the equations that will basically take part, it's Fk, but this one, since it's not parallel to the displacement, we cannot consider it, but we are going to take its component, which is Fx. Remember, Fy is somewhere here. So the equation will consist of Fk and Fx, the horizontal component of the force applied. So from here, we know that the horizontal is Fx is equals to F cos theta. So we are going to have F applied x, and we know that the F applied x will be positive since we take right as positive and then we are going to take left as negative. So all the forces facing to the left direction, they will be negative. So we have negative Fk is equals to ma. From here, where we see F applied x, we can put F applied cos theta minus, we know the equation of Fk in this situation, it will be coefficient multiplied by mg minus F sine theta. If you don't know where this equation comes from, I advise you to look at or watch the lesson video based on normal force and kinetic friction. It will explain everything. So we have F cos the angle is 20 degrees minus the coefficient is 0.4 and then the mass is 50, 9.8 minus F sine 20 degrees Now since the system is moving at constant speed, we should know that at constant speed A is equals to 0. So 0 multiplied by m is actually 0. And then from here we can work out F. So we can distribute this 0.4 such that we have F cos 20 degrees minus 0.4 50 9.8 negative and negative, it will be positive 0.4 F sine 20 is equals to 0. And then from here we can factor out F. So we have F cos 20. We factorize F from this term and also this term. So factorizing F from this term, we have positive sine 20 multiplied by, let's actually do this, 0.4. It's equals to, we transpose this to the other side such that we have positive 0.4 59.8. Then from here we can divide by this cos 20 plus sine 20 0.4. We divide both sides. Remember, the mathematical operation, you can take it in many ways, but what is important is the actual answer. So F is equals to 0.4 59.8 cos 20 degrees plus sine 20 0.4. So we actually punch this on the calculator and then we will get our answer. F is actually 182.071 newtons. So this is the value of F. Let us quickly go to the next question. Calculate the normal force. Normal force, the equation is equals to mg minus F sine theta. Now N is equals to the mass, it's 50 kg, 9.8 minus the force, it's 182.071 2.071 sine 20 degrees. Then we can quickly find the answer. Our normal force is 427.73 newtons. There is a lesson video based on normal force. If you watch that video, you'll understand where this equation comes from. Let us quickly go to the next question. The frictional force, we are here now. This is the equation to calculate the kinetic frictional force. So Fk is equals to, we know the coefficient is 0.4. And then our normal force is from the previous question, 427.73. Kinetic friction is 171.092 newtons. That's it for this lesson video. This is Fahula SJ. Thank you very much.